Decision table testing. Hi, and welcome back to another black box or specification-based technique, which is decision table testing. Some specifications contain that complicated logical conditions or complex business rules. Different combinations of conditions produce different outcomes or actions. To test such specifications, we need what we call combinatorial test techniques. Decision table testing is one of those combinatorial testing techniques. Decision tables are a good way to record complex business rules that a system must implement, and testers use this table to create various test cases. A decision table often lists all conditions, often inputs, that can occur at the top of the table, and all the action, often outputs, of the system at the bottom of the table. We should generate the table using those conditions and actions. Each column generated corresponds to a decision rule that defines a unique combination of conditions which results in the execution of the actions associated with that rule. Let's start by a simple example to understand it better. A company that sells car insurance asked you to develop software for them. The software requirements for calculating car insurance premiums are as follows. For females between 18 and 64 years of age, the premium is $500. For males between 18 and 64 years of age, the premium is $1,000. For anyone 65 years of age or more, the premium is $1,500. Anyone less than 18 years of age cannot get insurance. The question is, what is the minimum number of test cases needed to test this requirement? Let's build together the decision table for this piece of requirement. So we would have the sex of the insured person, which could be male or female. Well, I'm an old-fashioned guy, so we have only 2 values for sex. Some websites have over 18 values of sex. Anyways, as for the age, we have less than 18, between 18 and 65, and older than 65 as input conditions. Some possible actions to be taken by the system could be 500, 1000, 1500, and not applicable. The fundamental question that you might be asked in decision tables is what is the number of test cases needed to test this table? The answer without creating the table would be 2, which is the values of the sex variable, multiplied by 3, the values of the age variable, equals 6. So you need 6 test cases to test all combinations of the values in this decision table. This is a very basic formula that you need to be very careful when to use it. To apply the above formula, the conditions must not overlap, meaning no value of one condition gives the same meaning of a value of another condition. I will give you an example. When I asked my students to build this table, a student might decide to use is male as a condition and is female as another condition. Well, if you use the equation blindly, you will end up with 2 for is male and 2 for is female and 3 for the age, and you will end up with 12 test cases. But actually, you would have columns where is male equals true and is female equals also true, both male and female. So let's not get into sexual orientation discussions again, but according to the guys of the ISTQB, this is not possible. Same thing when columns hold is male equals false and is female equals false. The person is not a male nor female. Well, we don't insure aliens in this company, so this is not possible as well. Another example where I have seen most students fall into is to have the age not as a 3-value condition like I did, but as 2 different conditions. One is less than 18 and the other is greater than 65. So in our formula, instead of multiplying 2 by 3, we will multiply 2 by 2 by 2. Again, we will end up with 8 test cases, not 6. So this is again not possible, because if you think about it, you will end up with columns where the age is both less than 18 and greater than 65, which is still not possible. So you need to be very careful when you use the above formula. Okay. By the way, I use the age here that has 3 values. Most books or most courses will teach you that each condition will hold only true or false. Well, if all your conditions are true or false, then you can use 2 to the power of whatever number of conditions, and you will end up with the right of test cases. This is exactly like multiplying 2 by 2 by 2 by 2 and so on. But I used the age here that contains 3 values just to give you a more clear idea of how to build this formula or how to use this formula. Most of the time you don't need actually to build the table yourself, but just use the formula quickly. But of course you can build the table just to make sure no columns requires special handling from your side. I will populate the table with the actions according to the given requirements just to give you the full picture. To represent those values on the decision table, the values of the conditions and actions are usually shown as Boolean values, true or false, or discrete values, red, green, blue, or as range of numbers like in our example, less than 18 and between 18 and 65 and greater than 65. These different types of conditions and actions can be represented together in the same table. The common notation in decision tables is for conditions. Y means the condition is true, also you can use T for true or 1. N means the condition is false, also you can use F for false or 0. Dash indicates the value of the condition doesn't matter, maybe also shown or written as not applicable. For actions, X means the action should occur, may also be shown as Y or T or 1. Blank means the action should not happen and also may be shown as dash or N or F or 0. So when we populate the values of our car insurance example, we must make sure we have exercised all the possible combinations of conditions, both valid and invalid combinations. Such table that exercises all possible conditions is called complete table. So let's try all the possible combinations in our example. To achieve full coverage, we should have at least one test bare column in the decision table. So we should have 6 test cases to achieve full coverage in our example. And remember, test cases contain actual data. So I will choose Dan age 16 and John age 40 and Sam age 70, Linda age 14 and Sue age 32 and Joanna age 66. The decision table could be a good tool to evaluate the requirements, as while building the table, we might discover some combinations of conditions have not been mentioned in the requirements, which in that case, we should go back to the system analyst and ask for clarification. The questions in the ISTQB exam related to decision table testing vary. One example might give you the table and situation of a specific combinations of the conditions and ask you what the action will be. So if we have David, who is 43 of age, so how much should he pay for the premium? Answer is 1,000. Or they might have already ready-made test cases for you and ask you what are the remaining needed test cases to achieve full coverage. The hardest one would be like our example here and ask you to build the table from scratch, which I have seen very rarely to happen, and ask you to determine how many test cases are needed. I would use the formula but I have to be very careful, as I said, when I decided the values for each field or each condition. The questions are easy, but few get lost moving around the table, so you need to open your eyes widely while answering those questions. Hope this was clear. The common minimum coverage standard for decision table testing is to have at least one test case per decision rule in the table, as I mentioned before. This typically involves covering all combinations of conditions. Coverage is measured as the number of decision rules tested by at least one test case, divided by the total number of decision rules, normally expressed as a percentage. The strength of decision table testing is that it helps to identify all the important combinations of conditions, some of which might otherwise be overlooked. It also helps in finding any gaps in the requirements. It may be applied to all situations in which the behavior of the software depends on a combination of conditions at any test level.